Okay, sir. Thank you, sir. Okay. Hi, Ashwini. Actually, today you once joined, but no problem. We will start the session, and they will the recordings are there, no? So they will take care of it. Okay. And please reply
Okay.
whether my screen is visible or not, whether my screen is presenting or not, like my voice is audible or not, like that. Please reply. Okay. Okay.
Okay.
Okay. Actually, I'm presenting my screen now. Is it visible?
Yeah, it's visible.
Okay. Okay. Thank you. Okay. We will go through once again. And as of yesterday's session, in every session, we tell some correction, no? Not like correction, some alteration like that. In this session, there is one small modification like it. In this PPT, there is a signal called low packet valid. Okay, where it is. See, in this FSM, below this P for full, there is a signal called low packet valid. Actually, the low packet valid is for it will detect whether the last bit is came or not. Okay, for example, see, this is our frame format. Okay, and let's say that first one is address. Okay, length plus address, and second one, from second one also, from second byte onwards, our payload will start, and then our last byte will be the parity. Okay, so once this, someone has joined. Okay, okay, once this last parity, that is once this last byte came, that low packet valid will on. That is what low packet valid is for. Okay, so if low packet valid is in high state, it means it is our data, that is our packet is going to send the last byte. Okay, that is what it is for. Okay, so previously I think I told like it is some to pass some minimum amount of data, like that I told, but it is not. Actually, the thing is that low packet valid is for is to indicate that whether our packet is sending the last byte. Okay, that is it. Okay, okay, let's come again. Once again, we will review this, uh, recap this. Okay. So as I told, router is a NOC. NOC means network on a chip. Network on a chip in the sense, actually inside our SOC we have plenty of blocks like processor, and we have memory, like that we have. So to take data from one block to and deliver it to another block without any traffic and without any congestion, we use a router. Okay, and basically router will send data in terms of packet. Okay, that packet will have a header, a format. Okay, packet format, and it will be the first byte will be header, and the remaining is called as payload, and the final one will be parity byte. Okay, and this is our router architecture. I will explain this once again. Yesterday I think we have seen this, but no problem, I will explain this once again. And this is our pin diagram. See, there is a clock reset, which is a global signal, and then we have a packet valid. This packet valid is different from our low packet valid. Okay, so at the starting of our byte, okay, at the starting of our byte, that is, it will pass. See, according to this packet format, the first byte will be our address and the length of this payload. Okay, so this packet valid will be on. That is, this packet valid will be asserted at the first byte. Okay, whenever we are receiving our first byte, this packet valid will be in is asserted. Okay, then we have busy and error. Okay, if our destination is not receiving the proper data, okay, or it is our parity is mismatching, okay, that time this error signal will be thrown. Okay, it will be asserted. Or else, if our destination is doing some other work, okay, it is busy, that if our FSM is doing some other work, and if our router is managing with some other data, it can't accept the packet right now and it can't process it, then the busy signal will come. Okay, who handle this busy signal means FSM. See, see in the FSM, see the fifth signal, there is a busy. Okay, FSM will handle the busy. So what this busy means, if our router is doing some other process, right now it can't get the packet and process and give it to the destination. In that state, our FSM will produce a busy signal. Okay. Okay, then we have a data. Okay, data in the sense, as we all know, the packet. It will send the packet through data in, and it will send the packet out to the through the data out signal. Okay, so as in our project we are using 1x3 router. Okay, so we have one source and three destinations, so we have three data out signals. Okay, so this valid out is for whether our output data, that is the data which coming out from the router, okay, is a valid or not. That is what if this valid out is on, that is if this valid out 0 is asserted, that means the data out 0, that is the output which going to reach the destination 1, that is P41, is a valid signal, like that it means. Okay, then read enable in the sense, if our, see here in our FIFO, okay, if read enable is high, then only our FIFO can read. Okay, then only that what it means, then only our FIFO is ready to read a data or a packet. Okay, that is what this read enable is for. So as we have 3 FIFOs, we have 3 read enables. Okay, okay. Then as I told you before, there is a low packet valid. See here, wait. See in FSM we have low packet valid, and see in register also we have low packet valid. But here you should notice one thing. In register, let's go to this architecture. See here, there is a register, and see the second signal is low packet valid. So if our register came to know that the packet which is in process right now is the last byte, if the register came to know that, then packet low packet valid will be high, so that our router will know, okay, this one is the last byte. So what is our last byte? It is parity. Okay, that is what this low packet valid is for, and we will clearly understand in the FSM diagram. Okay, okay, this is TCP and IP model, and actually our all this process, the router will takes place in the, once again, one second please. Okay, actually right now we are going through this PPT, that is these slides once again. Okay, okay, then actually all this packet are going to takes place in the network layer. Okay, all the transfer and receiving, all these are going to take place in the network layer. Okay, and as I told, this is our packet format. See, we can notice one thing, that when the reset is actually, we can notice that reset actually it is a active low. Okay, what it means? Active low in the sense, whenever reset is 0, then it will do its process. Okay, if we pass 0 to the reset, then the reset will be high. Okay, that is the reset is asserted. Okay, that is what it means. Okay, see here, our there is a one more signal, packet valid. As I told you, see, we can notice one thing before starting. Okay, before starting our packet. Okay, before starting of the packet. Okay, or at the time of the first receiving of the first byte in the packet. Okay, this packet valid will be asserted. Okay, once again. Okay, okay. Actually, we seen this yesterday itself, but no problem. See here, this is the starting of our packet. This is the first byte, that is our header byte. Okay, so this header will contain the address and length of the channel. Okay, so if the packet is valid, that is the packet will be high, then the first byte, that is header and following data payload, and then at last parity. Okay, so as I told you yesterday, for parity the packet valid signal no need to be high. Okay, So see here, if we pass the busy signal, our transfer will extend. Okay, what it means, our router is doing some process, okay, on this. So it needs some time to process this header. So busy signal is passed. Okay, so it will extend the transfer. Okay, see at last after passing this parity bit. Okay, see here, error is produced. Okay, what it means, some parity mismatch may happen or some parity mismatches happen. Okay, see here, and here you can see as I said before. Okay, see here, before the packet, see the first packet, that is before the header is sent. Okay, our packet value is high, then after our packet value is high, the first header byte is sending. Okay, then following the payload, then finally we are getting the parity. Okay, so for parity, as I told, packet value is not needed. Okay, so see here, while receiving the payload, okay, the one more signal should be high, that is valid out. Okay, if the valid out is high, that is also in the reception side. Okay, see here, in the output side, if the valid out is high, then what it means, our output is a valid one, so we can receive. So see, after the read enable signal is asserted, then only we can read the header, payload and the parity. Okay, so these are all some conditions. Okay, so before sending the data out, our valid should be our valid out should be asserted, and before reading that packets, our read enable should be asserted. Then only we can read. These and all conditions. Okay, we should follow. As I told, there are totally three components, four components. One is our FSM, one is FIFO, and one is synchronizer, and one is register. Okay, we use three FIFOs because we have three destinations. Okay, and this is the pin diagram of FIFO as we discussed yesterday. And this one is FSM. And once again, I'm telling, this low packet valid will indicate that our packet is transferring its final byte. Okay, whenever we receive our final byte, then this low packet valid will be high. What it means? After that, there is no packet. It is going to complete. This is the end of the packet. Okay, like that. For in that condition, low packet valid will be high. Okay, we discussed it. Okay, today we will discuss this FSM. Okay, FSM, and we will discuss with the architecture. Okay, we will discuss with the FSM and architecture. Okay, and I will give you some time to ask doubt. And if you have any doubt, you can ask. Great. This is our FSM. And before going to FSM, yesterday one person asked me like a doubt. Okay, so at the same time, wait, for that we will take the architecture diagram. Okay, because then only it will be fine. Hmm. This is our architecture. Okay, see, yesterday one person asked a doubt. Okay, at the time, okay, both FIFO, if at the time two FIFO got full. Okay, that is if our FIFO 1 is full, okay, and our FIFO 2 is full at the time. Okay, see, our FIFO 2 is full, then that signal will be received by synchronizer and it is transmitted by FIFO 2, and our FIFO 1 is also getting full. Okay, see here, and it is going and it is received by the synchronizer. Okay, so at the same time, then what will happen? Like that, yesterday a person asked a doubt. So what happens is, as I told, it will maximum it will not happen, or if it happens, okay, why I am telling is our router can send the packet uh, to any one of the destination at the time. Okay, so obviously either our FIFO2 may come full, may attain the full state first, or FIFO1 can attain the full state first. Okay, either FIFO1 or FIFO2, but any one can attain first. Okay, But in our case, if FIFO2 is getting full, then suddenly FIFO1 is also getting full. What happens? Okay, what happen is our FSM will take that FIFO2 first. Okay, see here, our full state is FIFO full signal is there, no? It will be transmitted to the FSM. Okay, so what our FSM do is it will make uh, the process, that is it will make the packets of the FIFO1 to wait, or if our FIFO2 is attains the full state, in our case FIFO2 is getting full first. Okay, then FIFO full signal, see here in the synchronizer FIFO full signal is there, no? It will be transmitted to the FSM. Okay, now what FSM do is our FSM will make this FIFO2 wait, okay, until it gets some space, okay, to store a packet, to store some data, okay, and then FSM will start doing its work as usual, okay. At that time, if FIFO1 is also full, then once again this FIFO full will be passed to the FSM. Then once again the packets which is going to the FIFO1 will be in wait state till the FIFO1 is getting some space to store some data. Okay, this is what happens. Okay, so once a FIFO becomes full, see where we can see this is, see here in the FSM, our data is here. If our FIFO is full state, okay, what happens? See, it is waiting. Okay, you can notice, no? Wait, see here. If our data is full, what is happening? We are getting our FIFO full state. Okay, see here, our FIFO full is waiting here itself. Okay, why it is waiting? Because we have no space to store. Okay, then notice this signal load after full, and here what is the condition? FIFO is not full. This is the condition. What it means? Now FIFO is having some space to store. In that case, load after full. That is, once our FIFO is full, then it is getting some space. Then now we are loading after getting some space. Okay, that is what load after full is. Okay, so from here only I am saying, in case if our FIFO2 is full, it will wait for some time, okay, until it gets some space, okay. Meantime, our FSM will make that FIFO2 to wait, and it will do as its regular process, okay. Then at that time, if FIFO1 also full, same, it will also wait till it gets some space, okay. After getting the space, it will load some data. After that is what load after full state, okay. We will explain this FSM, no problem. But for as of now, for understanding, I'm telling. Okay. So let's start from FSM. As we are having clock and reset, the first will be address. Okay. See here in FSM, the address detect is passing to the register. Okay. And then see here, it is also passing to the synchronizer. Okay. So once the address is detected, which signal will be high? This load first data will be, this state will be asserted. Why asserted in the sense? See, after the address is detected, what we are going to do? We are going to load the first data. Okay. So once the address is detected, we are going to load the first data, and that load first data state will be given from the that state, that control will have FSM will have the control, and FSM will give the signal to register. Then register will make that IFT state asserted. Okay, asserted means it will on that signal, high signal. Okay, this is what happening here. So after IFT state, that is load first data. After we are loading the first data, then our register will start loading the data, actual data, that is load data. Okay. And after loading the data, see here, we have low packet value. That is, whenever we are getting the final byte, okay, that is our packet is going to end. It is the that byte is the end of our packet. If in that case, what it will do is, it is going to activate. That is, our register is going to activate. In the sense, it is going to assert the low packet value. Okay. See here, it is asserting this low packet valid. Okay. And that low packet valid will be given to this. See here, it is given to the FSM. Okay. What it is giving? Can anyone tell? See here. Wait, 1 second, we can check now. Just going here. See here, in this, it is going to the FSM. Okay. You can notice here now. See here, this low packet valid is this signal is asserted by the register. Okay. Whenever the register came to know that, okay, this signal, this byte is the final one, then this low packet valid will be asserted and it will be given to the FSM. Okay. Why we need to give to the FSM? Because see this FSM diagram. See, whenever the low packet valid is high, see here, whenever the low packet valid is high, but parity is not done. Why parity is not done? Still parity need to be checked. Okay. So we are receiving that low packet valid, but still it is not getting that parity done. Parity done in the sense, it is like we are still our parity is not checked or our parity may have some mismatch in that state. Okay. It will move to this load parity. Okay. Load parity in the sense, now only we are going to load the parity. Okay. That is what it means. What it means is, see here, once we came to know that this is the low packet valid, that is, this is the final byte of the packet, we will move to this load parity. Why we are moving to this load parity? Because we will load the parity. Okay. Then after loading the parity, because final byte is what? Parity byte. Okay. So we need to load the parity and we will send this to the parity check error. What this parity check error will send means the actual sent data. Okay. See, while sending, we will have some parity. Okay. We load some parity and at the receiving end, we will get the data. It also have some parity. So we should check whether the sending side and reception side have the same data, have the same parity. Is there any mismatch or not? Like that, we need to check. Okay. So if our FIFO is not full and if our parity is, if our FIFO is not full, it is going to, that is, if there is an error and FIFO is not full, it is going to decode address state. But in case our parity is done, see here, this signal, in case our parity is done, it will be transferred to the decode state. Once again, it will start from first. Okay. So from this only, we are telling like whenever this low packet is high, it will be given to the FSM. Then suddenly it will start the work of the parity. Okay. It will start checking the parity, sending the parity byte. Then once the parity is done, it will be given to the, see here, the parity signal is here. It will be given to the FSM. Then after parity done, we will start once again with the address direct. Okay, direct address. Okay. So when it comes to this FIFO side, okay, anyhow, we will see the FSM next. But right now, when it comes to the FIFO side, see here, this is LFT means load first data. Okay. So we are receiving the signal. So it will be the load first data signal. Okay. What it means, we are receiving the first signal. And as I told you, there are two types of reset. That is, one is soft reset, one is hard reset. Hard reset in the sense, our signal will be reset by as. Okay. That is, we are going to reset. Okay. The signal. That is what hard reset is. And in this case, our output will be 0. Okay. But when we are doing soft reset, okay, soft reset in the sense, it will automatically resetted. When it will automatically reset in the sense, after passing a data, our FIFO is not processing it. Okay. It will wait for up to 30 cycles. Okay. Then till that 30 cycle, there is no response. Then soft reset will happen. So inside that soft reset, what happens is our signal, that is our reset will go to high impedance state. Okay. Instead of getting 0, it will be moved to high impedance state. High impedance state in the sense, our signal will be disconnected. Okay. So it may, we may connect it whenever, but instead of making that 0, we are making it to the high impedance state. Why we are making it to the high impedance state in the sense, we are not that signal is there. Actually, there is some data. Our FIFO may get that data, okay, but still it is not responding. So instead of clearing that, we are just disconnecting it temporarily, okay. After it is not permanently having any response from the FIFO techniques, then we can do hard reset. But see, where we have that information in the sense, we should move to this coding part, okay. Coding part we will discuss separately, but as of our knowledge, we should know, no. See here in this FIFO, actually, here you can see here in this 18th line, else if soft reset. If soft reset happens, see what we are doing. Instead of making signal 0, that is data out 0, we are making it to high impedance, okay. As I told, high impedance means a disconnection, okay. So that particular connection, the bus will not happen there, okay. The process of bus, what is the process of bus? It is going to transfer the packet, okay, here in this case, okay. It will not happen, it will be disconnected, and our transfer will be happen to some other place where it is required. It will go to that place and it will be temporarily disconnected, okay, and there will not be any data transaction or reception will be happened, okay, in this particular data out, okay. This is what high impedance state is. And see, the same is happening here. If soft reset is done, then high impedance, it will move to the high impedance state, okay. Then there is FIFO full and there is FIFO empty. Why we are using it is, whenever our FIFO is full, this FIFO full signal will be activated. But why in the sense, see, if we are going to write something, okay, but we are getting a FIFO full signal from the FIFO, okay, so that we can avoid writing, okay, we can avoid the time. Instead of making the write enable and instead of trying to write some packet into the FIFO, before itself we came to know that, okay, FIFO is full, then we can avoid that and we can wait for some time or we can do some other process, okay. That is what this, or we can avoid waiting. Our source will avoid that waiting time, okay. That is what this FIFO full. And why FIFO empty in the sense, if you are trying to read something and if our FIFO have no data, then it is waste of time to attempt that read enable, okay. So that is why these signals are here, and it will also indicate whether our FIFO have data or not, okay. If empty is high, that means our FIFO have no data. If full, our FIFO is full, that is it have data and there is no space to store some data, it means, okay. This is what the architecture is. And yes, there are signals. I will actually, I think you have received this PPT. You can go through, and if you have any doubts, you can ask. Next, we move to this FSM. Okay. See here, the first one is address decode. Okay. Address decode in the sense, see here, you can notice one thing. The reset is active low. Okay. That is, it is 0. Okay. The reset will be done by us. Okay. See, we are going to reset. That is hard reset. Okay. Here, actually, here there will be not soft reset and all. Okay, you no need to confuse with the FSM. FSM will have some operation. It is like a state. Okay, it will control after in this state from next to where we need to move. Next to what is the state? Like that, the FSM will tell the information. For example, if we are in address decode stage, the next stage will be load first data. Okay, for that there are some condition. Based on the condition, we should move. Okay. So this is what this FSM is. See, defaultly it will be in address decode, that is decode address state. Then you should notice one thing, if our packet is valid, okay, and if our address is known, that is, see here, they are using the first two bit, okay, first two bit is of destination, that is address bit. We have three destinations, no? So in that three, where we are going to pass our packet, okay, and that should be known to us, okay. Before sending some packet, before sending the packet, we should know the destination and then FIFO empty. Because before sending a packet, we should know whether our FIFO is having space or not. Okay. See here, there are three conditions. Why there are three conditions? In the sense we have three destinations, so they have given three conditions. Okay. If any of the condition is high, okay. If any of the condition is high, okay, there are three conditions. If any of these three condition is high, they will move to the load first data. Okay. Or else, if our FIFO is not empty, okay, because we are going to load some new data, then we will expect that our FIFO should be in empty state. But if our FIFO is having some other data, okay, what we should do is the remaining are all same condition only, okay, the destination address and the packet valid. But if our FIFO is having some data, we need to empty it. Then what will be the next state is wait till empty, okay, wait till empty is it will wait till our FIFO is getting empty, okay, and it will keep on, okay, in the same state. Once our FIFO is getting empty, see here, this condition, FIFO is empty and our address location, okay, our destination address, okay. Once our FIFO gets empty, then it will move to the load first data state, okay. After loading the first data, what will happen? Unconditional in the sense without any condition, okay, because after loading the first data, it will going to load the parity bit, actual payload, okay, it's not parity, it is going to load the actual payload. Then there is no condition. After loading the first data, it will load the payload, okay, as of the packet format, okay. So see here, after load first data, it is moving to the load data, okay. So here only actual payload will be loaded, okay. So it will be happen, okay. How many payloads we have, it will load here in the same state, okay. So once our FIFO get full, okay, see, once our FIFO get full, FIFO full state will be enabled, okay, it will move to the FIFO full state, okay. Or see here, if our FIFO is not full, okay, and our packet is invalid, our packet is not valid. See here, they are using a symbol, no, not symbol. I think you can see this. See here, our packet is, if our packet is not valid and our FIFO is not full, what it means? See, if when our packet valid will be reasserted, whenever our packet is going to send the final data, that is the parity bit, okay. Because in as per our frame format, our final byte is parity, okay, it is going to check the parity, it is a parity byte, okay. So whenever our packet reaches the parity byte, our packet valid will be low, okay. Note this, whenever our packet reaches the end byte, that is parity byte, our packet valid become low. Then which one become high? Low packet valid become high, it will indicate, okay, we reached the final packet, final byte of the packet, like that it will indicate, okay. So in this condition, see, after load data, if our FIFO is not at full, that is our FIFO is having some space, at the same time it reached the end of the packet, so packet invalid, it will go to the load parity state, okay. So after we are loading the parity, what we are going to do? We are going to check the parity error. If there is error, parity error is there or not, like that we will check. Okay. So then we will move to this. If in that case, if our FIFO is full, okay, then we will move to this FIFO full state. Then once again, we will, in case if our FIFO is full, in that particular case, if our FIFO is full, then we will move to this FIFO full state, and once again we wait till our that is we will wait till our load after full, that is our FIFO, still our FIFO is have some space, no, it once it get full, then we will wait till our FIFO get some space to store the packet, okay. So after that we load after full, but here there is one more condition, that is once again moving to this decode address stage, okay. It will check the parity error, okay. Then it will move to the decode address, okay. And there is one more state, that is FIFO full, Okay, in case if we are loading some data and we still have some data, but unfortunately our FIFO is getting full in sense. Okay, in that case, we will move to this FIFO full state, and from this FIFO full state, okay, we will wait till our FIFO gets some space. Okay, after our FIFO is getting some space, what will happen? It will go to this load after full. See the condition, if the FIFO is not full. When the FIFO becomes not full, once it gets space, once it is getting some space, it will come to this FIFO not full stage. Okay. And when this condition is passed, it will be moved to the load after full state. Okay. So from here, it will be moved to this load data. Okay. When it is moving to the load data, when the parity is not done at the same set, okay, when the parity is not done at the same time, load packet valid. Load packet valid means, as I told, low packet valid in the sense it will describe the end of our packet, okay, the end bit of our packet, okay. Before, if this is not the end, what this particular condition is telling is this is not the byte is not the end of the packet and the parity is not yet done. So in that case, it will once again move to this load data state, okay, or else our low packet valid is asserted. That is, our low packet valid is asserted. That is, we are getting the final byte of our packet and the parity is not done. Okay, that is, then we will move to this load parity. Okay, or our parity is done. That is, there is no mismatch. Okay, in that case, if we in that case we will directly move to the, that is, see here the condition, that is parity done, and we will move to this decode address. Okay, 1 second please. Okay, okay, sorry. Okay, we will continue. See, that's all. This is our FSM. Once again, I will explain. Okay, this final explanation for your clarity. Okay, we will come across this once again and we will move to the design. Okay, after reading this, I think there are some more slides. Okay, what about your opinion? Today we can see our design, or tomorrow we can start? See, this is our design. See, this is our design. Okay, it is written in Verilog. Okay, so what about your opinion? Today we can start the design, or you need to go through this PDF and you need some clarity, or we can start tomorrow, or we can start the design today itself.
Sir, we didn't get the PDF yet.
Actually, I told them to start. You didn't get a.
Yes, sir.
Actually, in which group you are?
Sir, just a minute. Advanced ASIC design
Yeah,
verification.
actually, I think we have shared today morning. Check it once right now. It is shared or not? Not shared.
No, sir. There is a
Okay, okay.
last we got only risk. We didn't get anything related to router actually.
Oh, okay, okay. Okay
And
then.
these recordings also. So, sir, first please share, then by tomorrow start the design.
Okay. Yesterday's session, that recorded session is shared or not?
No, nothing, sir. Nothing shared for about router.
So that risk you get no? The PPT
Yeah,
material recorded session
risk we got all material.
and the
Uh,
recorded session also
Recorded session, sir.
for risk. Okay, okay, no problem.
No,
Okay,
sir.
I will tell to share. Okay, it will be shared
Yeah,
soon.
yeah, yeah. Project we didn't get anything. Only risk
Okay,
PDF we got.
okay, okay, okay. We can we can continue the design today, or we can continue our design by tomorrow. What about your opinion? Not only for overall, okay? You have some opinion, no? Like we
Yeah,
need
sir,
to go
can we
through.
start by tomorrow? First, we go through the all fall FIFO and those all things.
Okay, okay then.
The basic, and
Okay,
please sir, share the PDF. Yeah.
okay then. Okay, now right now I will explain this FSM once again, and then we
Okay.
will complete this theoretical part today. And then today we can opt our session, today's session. Then I will tell them to share the recorded session and the materials. You can take time, and by today, tomorrow evening we can continue. Okay, we can start the design. Okay, this
Okay.
is today's agenda. Okay, then we can start with this router FSM once again. Okay. See, this is final explanation. Once again, I will explain because I draw some diagram and here and there. Okay, so it might be difficult. Once again, I will explain clearly. See here, first one is decode address. Okay, decode address in the sense it is the first state. Okay, address state, and then after our packet is valid, that is after we are start getting our data. Okay. Okay, actually our data is ready to process. In that time, our packet will be valid. Okay, then we will get the address data in first 2 bit. First 2 bit will be the destination address. Okay, this data in 1 is to 0 is equal to 0 in the sense it is what it is indicating is it is indicating the first FIFO. Okay, the first destination. Okay, see the packet valid and data in is equal to 0, and if FIFO is empty it will move to the load first data state, and if our FIFO is not empty then it will wait till the FIFO is getting empty, then it will move to the load first data state here. Okay, then it will then after loading the first data, unconditional in the sense without any condition, after loading the first data it will move to the load data. Okay, so if our load data is not full, okay, if our load data is not full, at the same time if our packet is not valid, that means if our load data is not full but we are reaching the end of our packet. Okay, sorry, if our FIFO is not full. Okay, if our FIFO is not full but we are reaching the end of our packet, that is the end byte of our packet. Okay, if we are reaching this condition, then what the next will be, we are going to load the parity because the last byte is the parity. Okay, we need to load the parity and we need to check whether the received parity and the parity which we have sent is uh, correct, is matching or not. Like that we need to check. Okay, if it is not matching, it will see here, it will check the parity error. Okay, if it is error, then what we do, we can't do anything. Okay, if the parity is mismatching, then it will go to this decode address. Okay, see here, what is, if our FIFO is not full and our parity is also not getting its condition means, then it will go to this decode address. Okay, else see here, it will come to this FIFO full state and it will wait for some time. Okay, it will wait for some time till our FIFO is getting some space. Okay, wait 1 second. I think some small mistake is made. Okay, okay. First we will start from this. Okay, from the load data. Okay, see, after loading the data, if our FIFO is full, okay, but we have some other data to load, but our FIFO is getting full. Okay, in that case, what happens is our FIFO will wait for some time. Okay, until we are getting some space. Okay, so after getting some space, see here, FIFO not full will be enabled. Okay, this in this condition, that is if FIFO is not full, that is we get after we getting some space, it will be moved to the load after full. Okay, so in the load after full, we can notice one thing, in the load after full, this is if we are load the final packet. Okay, and our parity is done here itself. Okay, after loading, because our FIFO may don't have space to particularly store that parity bit alone. Okay, in that case also it will be considered as uh, some space. Okay, some inconvenience in the space. Okay, so in that time we need to wait. Our FIFO full state, it will be, so our FIFO will wait until we get some space. Okay. After that, we are going to move to the load after full state. So at that state, if our parity is checking and if it is done, okay, our parity is done, then it will move to the address, okay, decode address. One second, okay. Else, if it is not the final bit, okay, that is, if it is not the final byte, we have some other extra data payloads to be loaded. Okay. So in that case, it will once again move to the load data. Okay. So you can notice that. Wait one second. See, you can notice that. See, in here, see this condition. If our parity is not done, that is, our parity is not yet done. At the same time, our low packet valid is not full. Okay. So in this case, what happens is it will once again move to this load data. Okay. As of our understanding, this will be the first state. That is, we can make this one as the zeroth state, and this load first data will be the first state. Or else, if our FIFO is not empty, okay, sorry, if our FIFO is empty, then this will be the second state. And then after loading the first data, after loading the first data, we will move to the load data. This will be our third state. For your understanding, I'm telling you. And then if our FIFO is full, okay, if our FIFO is full and packet is not valid, that case we will go to this load parity, and after load parity, we are going to check the parity error. Then we will move to this decode address state, okay. And if in, see here, you can note this, our FIFO is not full yet, okay, it has some space, but here we are loading our parity. Then once again we are checking the parity. Then we will move to this decode address state. Okay, that is decode address state. Or else, see, let's consider this one as the fourth state and fifth state here. Or else, what will happen is here. Okay, if our FIFO is full, it will be going to this FIFO full state. Then it will wait until we get some space. After getting the space, it will be going to this load after full state. Okay. Then in the load after full state, if the parity is done, okay, if everything is okay, once again it will be moving to this decode address, or else we have some other packets to store. Okay, we have some other data payload to store. It will move to this load data. Okay, then it will come once again. Okay, this is what the FSM is. Okay. Okay, is there any doubt in this FSM particularly? Or wait one second. Okay, is there any doubt particularly in this FSM?
No, sir.
There is no doubt, sir. Okay, you can also go through. Okay. Okay. Right. See, I think in this place it might be confusing. After load data, it might be confusing. You can go through the recorded session once again, and you can refer in this, particularly after load data in this states like load parity, load FIFO full. I think it is done. Okay. After FIFO full, we are going to wait some time, and we are if our FIFO is getting some data, that is, if our FIFO is getting some space, we are going to load. Okay, I think this will be good. But this load parity, okay, you can go through this recordings once again. Okay, in this low parity, actually, the last byte is latch, that is, it will be detected. Okay, then it goes unconditional to the check parity error. Okay, so that's all now. Okay, this is conclusion. Uh, Okay, as we all know, a 1x3 router accepts data from one input port and forwards it to one of three output ports based on routing logic. So, data routing is efficient, reduces latency and congestion. Okay, reduces latency means slowness. Okay, and congestion means traffic. Okay, because of its multiple output paths, the router can help distribute traffic efficiently. Okay, reducing the chance of bottlenecks. This leads to lower latency in data transfer. What they are telling is this leads to lower latency. That means uh, it will reduce the slowness, okay, in the data transfer. Its design enables reduced latency, okay, improved throughput and better scalability in many core systems. So this is what this router PPT is of. And okay, you can take 5 minutes, and if there is any doubt, you can ask me. Anyone, not only this, in a whole PPT, in a whole theory. Is there any doubt, you can ask me. Okay. See, in FSM, you no need to confuse. Once again, our packet is invalid. That is, our packet valid is deasserted and our FIFO is not full. We are going to load the parity. And after loading the parity, we are going to check. And then after checking, we are going to send it to the decode address, or in case in that place, in that time, if our FIFO gets full, once again we will come to this FIFO full state and we will wait for some time, and once again it will go to this load after full, then it will move to the decode address after the parity is done. Okay, this is what they have given here. Okay, or else if our FIFO is in this case, okay, in this case, if our load in our load data, if our FIFO is full, it will directly come to this FIFO full state. Then it will wait for some time until we are getting some space, and then after getting some space, it will come to the load after full. But if it is it is coming to this final byte, that is the packet is going to end. Okay, it is coming to this end byte. Then see here, this low packet valid will be asserted, and till now the parity is not done. What happens is it will go to this load parity, then it will go to this check parity error, then it will go to the decode address once again. Okay, and you can notice one thing, and you can ask a doubt like, see here, our FIFO is full, then we are getting some space, then we are loading, and when we deduct, it is the last byte, and till now parity is not done. We are going to move to the load parity state. Then after that, we are going to check, and then we are going to the decode state. In between, there is FIFO is not full. Why FIFO is not full after getting full? That I'm telling you, after getting full, we are getting some space, no? So after getting some space, we are getting the final byte. So after getting after getting the final byte also, our FIFO may have some space. Okay. In that case, it will be moving to this uh, load parity, and it will check the parity, and after also if it is full, then once again this state, see in FSM all the state will be continued, okay, till the particular destination, till our packet reach the particular destination. Okay, 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 then go through the session once again, and if you have any doubts you can ask. The other any other doubts? Only one replied, I think. Remaining, is there any doubts not only in this FIFO FSM, in the whole PPT? You can go through the architecture also once again, and you can tell us. Okay, 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 if you have any doubts, you can ask or else you can leave. Thank you.